Okay, so today we're going to be working on 3.3, more interesting. This is another solidify understanding task. So it's building on the understanding that we learned in 3.1. It's developing the idea, it's introducing new side ideas, but it's all based on the main idea, which we learned in 3.1, which is how do you take part of a multiplication, a fraction of a multiplication with a fraction exponent. So let's start. Carlos now knows he can calculate the amount of interest earned on an account in smaller increments than 1 full year. He would like to determine how much money is in an account each month that earns 5% annually with an initial deposit of $300. So something I can already see is that he's looking at each month, but he makes 5% annually, 5% per year. He's talking about each month, and there's 12 months in a year. He starts by considering the amount in the account each month during the first year. He knows that by the end of the year, the account balance should be $315 since it increases by 5% during the year. Complete the table showing what amount is in the account each month during the first 12 months. So because we know that this is a exponential function, a geometric pattern, we know that this is through a multiplication. So from 300 all the way to 315, it's been multiplied by 1.05, right? This is one multiplication of 1.05. Now, we're going to take this one multiplication and we're going to break it up into 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So 12 multiplications should equal this single number. So this would be 1 month, 2 months, 3 months, 4 months, 5, 6, 7, 8, 9, 10, and 11 months. And then 12 months is 1 year. So to complete this table, what we're going to do is we're going to take 300 and we're going to multiply by 1.05. And this is 1/12 of a multiplication. It's 1 out of 12. So it's 300 times 1.05 to the power of 1/12. And to get an approximation, what we can do is we can plug that into a calculator. So we can do 300 times, I'm plugging it into a calculator right now, times 1.05 to the power of 1/12. Okay, and that's going to give me 301.22 cents. And so this is an approximation, which is what there would be. Okay, now what happens if we multiply it by another 1/12 of that, right? So this is multiplied by 1.05 to the 1/12. This is going to be times 1.05 to the 1/12. So this would be 2/12. And if we put that into the calculator, as an estimate, we get $302.45. I'm rounding to the nearest cent, you guys. So that even though my calculator actually says 302.449, I'm rounding to the nearest cent. Okay, now we're going to take this and we're going to multiply it by the same number again. Okay, and that's going to give us $303.68. We're going to multiply it by that again. That'll be $304.92. And then we multiply again, $306.16. Multiply again, $307.41. And then again, $308.66. $309.92. $311.18. $312.45. And $313.72. So I am multiplying. What number did you multiply the account by each month to get the next month's balance? The number I used is 1.05 to the 1/12, which if I put that in a calculator and I just estimate what that is, that's about 1.004, and that's an estimate. So that's not the actual amount, but that is close to the amount that we used. Okay, it says, Carlos knows the exponential equation that gives the account balance for this account on an annual basis is A equals 300 times 1.05 t to the t power. This is the equation that we used in 3.2. So that was in the last video, in the last task. This was the equation we had. Based on his work finding the account balance each month, Carlos writes the following equation for the same account. So Carlos writes this equation, I'm just moving that up right here. Verify that both equations give the same results using the properties of exponents. Explain why these two equations are equivalent. Okay, so looking at this, if I plug in 1, okay, I'm going to get 12 times 1, which is 12. I'm going to multiply this 12 times, so I'm going to get 1 whole. So when I plug in 1, t is basically counting as years. So what I don't want t to represent years, or if it does represent years, then these need to not be years. So if this is t in times, this should be 1/12 of a year, 2/12 of a year, 3/12 of a year, 4/12 of a year. 9/12, 10/12, 11/12, and then this would be 12/12, which is 1 full year. Okay, and that means to verify that both equations give the same results, using the properties of exponents to explain why these two equations are equivalent, we can use the properties of exponents to say that if I'm taking this right here and I'm multiplying it 12 times, that's the same as 1 full 1.05. So this is 1/12 of 1.05. So if I repeat this 12 times, it's like I don't even need this then anymore because I just canceled the 1/12. And that's what's happening here. So it says using the properties of exponents, explain why these two equations are equivalent. So I'm going to try to use the properties of exponents here. What I see here is 1.05 to the 1/12, 12 times. So what this is telling me is 1.05 to the 1/12 times 1.05 to the 1/12 times 1.05 to the 1/12 times 1.05 to the 1/12 over and over and over again. I've only done it 4 times so far, but I'm just going to put ... Imagine that this was done 12 times, right? So you had 12 of these. Well, if you have 12 of them and each one is 1/12, then in total you have basically just one full multiplication. So that's what's happening here. You're taking 1/12, but you're multiplying it 12 repeated times. So it's these kind of cancel out to each other, and that just gives you 1.05. So that's why these are actually equal to each other. Question 4, what is the meaning of the 12t in this equation? The 12t represents that if I put in 1, it represents the number of months that have passed. right? So 12t represents the number of months that have passed in t years, right? So whatever t is, 12t represents the number of months that have passed. So if t is 1, then there will be 12 years, or 12. If t is 1 year, then there will be 12 months that have passed. If t is 2, then that will be 24 months that have passed. If t is 1.5, then that would be 18 months that have passed, and so on and so forth. So 12t represents the number of months that have passed in t years. Okay, let's continue. Down. Carlos shows his equation to Clarita. She suggests his equation could also be approximated by putting this instead. And recall that that was the approximation that we had as well. We basically said that 1.05 to the 112th is approximately 1.004. So what Clarita is doing is, instead of putting 1.05 to the 112th, she's putting 1.004, which is an approximation. Oh yeah, look right here. It says, since it's approximate. Carlos replies, I know the 1.05 in the equation, in this equation, means I'm earning 5% interest annually. But what does the 1.004 mean in your equation? Answer Carlos' question. What does 1.004 mean in this equation? Well, if this meant that they were earning 5% interest every year, and when we took 1/12 of that multiplicatively, right, in an exponent, we've got this. That means that the money is earning 0.4%, not 5%, but 0.4% interest every month. So the 1.004 means that the money is earning 0.4%. Right? That's not even 1%. It's less than 1%, 0.4%. Right? That's a lot less than 5%. 0.4% interest every month. So that's what that represents. Okay. The properties of exponents can be used to explain why this is true. And we explain this in question number 3 and question number 4. Mainly question 3, we explain that this is true. Here are some more examples of using the properties of exponents with rational exponents. For each of the following, simplify the expression using the properties of exponents and explain what the expression means in terms of the context. Okay, so here we have 1/12, 1/12, 1/12. So since each of these is 1/12, these represent 3 separate months. Multiply them all together, it represents 3 months in there. So, and since we're using the properties of exponents, when we're multiplying these and the bases are the same, we can add up the exponents. So 1/12 plus 1/12 plus 1/12, that gives us 3/12, which is the same as 1.05 to the 1/4. So this represents 3 months of interest. That's what that represents. That represents 3 months of interest. Okay, right here, we've got 1/12 and it's being repeated 6 times. Okay, you can kind of think of this as, like, let's go back to number 6 real quick. You can think of number 6 as 1.05 to the 1/12 to the 3 power, because there's 3 of them. So if based on that, this one is the same, but it's to the 6th power. So this is, you're repeating the 1/12, 1.05 to the 1/12. You're repeating it 6 times, so that represents 6 months. We can say that's 1.05 to the 6/12 power, which is the same as 1.05 to the 1/2 power. and that represents 6 months of interest, half of a year. Okay, this one has negative 1/12. Okay, so that represents a division. You're dividing by 1/12. It also can represent, you're not dividing by 1/12, excuse me. You're dividing by 1.05 to the power of 1/12. It also represents the amount of interest if you go back 1 month, right? So it can represent, this can represent interest being taken away, reduced interest. Like another way would be to think about how much interest you had a month ago, right? In the past, not in the future, but in the past. So this would be 1 over 1.05 to the 1/12. So that just means you're dividing by this because it's negative. So that's what you're dividing by. And this represents 1 month ago, right? Going back, removing interest. Right? So you're getting rid of interest. Instead of getting more interest, you're getting rid of money. You're going back a month. Okay, this one, okay, again, you're multiplying, so we can add these. That would be 1.05 to the power of 2 1/4. We can change 2 to be 8 over 4. Like that. That way they have a common denominator. The exponents have a common denominator, so we can add them like that. So 1.05 to the power of 9/4. So what does this mean in the context? This represents 2 years, and this represents 1/4, and we already know that 1/4 is 3 months. So this is 2 years and 3 months of interest. Okay, let's keep going. Here we are dividing, and the rules of exponents say that when you divide, you're actually subtracting. So we have 2 take away a half. When you take 2 take away a half is 1 1/2, or it could be 3/2, we say. So this would be 1.05 to the 3/2 power. That would be, like I said, that's 1 1/2. So 1 year and a half of a year. That's 12 months and 6 months, so 18 months. This would be a year and a half of interest in the future. Okay, and question 11 asks us to explain. So it says, use this fact to explain why this fact is true. So what is this fact? It says here we've got our 1/12, right? And if we multiply that 12 times, we get 1 whole. So why is that true? That's because, or we know that that's true, right? We explain that. And it's asking, explain why this is true using this information. So in order to explain why this is true, we have to know that when you take a root here with an index, what the question it's asking is, what number times itself 12 times equals 1.05? The root, so I'm gonna write that down. The root with index 12 is asking what number times itself 12 times is 1.05. That's what it's asking. So which number is it, so that when you multiply it times itself, you repeat it 12 times, it equals that number that's in there. And the answer is this number, right? If I repeat this number 12 times, multiplying it repeatedly 12 times, I'm going to get 1.05. And so that's the number that would be the 12th root of 1.05. Okay. Before I continue, I want to ask you, as a student, make sure that you go back over that task that we just finished and internalize it. Okay, make it your own. Make sure that you're not just memorizing it, you're not just getting the answers. Make sure you're actually understanding. So if you have questions or if something doesn't make sense, ask your teacher or ask another one of your peers to explain. Okay, let's continue. We'll do the ready, set, goes. I'll show the answers here. So it says in the table below, there is a column for the exponential form, the meaning of that form, which is a list of factors, and the standard form of that number. Fill in the form that is missing. Okay, here we've got 1, 2, 3, 4, 5, 6, 7 sevens. This is 7 to the 7th power. To find the standard form of that number, we're going to use a calculator. We're just going to go 7 to the 7th power. I'll put up my calculator here so you can see. So in my calculator, what I can do is I can put 7, and then I'll press this button right here that says x to the y power. And what it does is it makes this little symbol here. This is called a caret, and that means you're going to put an exponent. Some calculators just have the little caret symbol as a button already, and so you can just press the caret and it does the same thing. Okay, so you're either looking for a button that looks like this, or you're looking for a button that has the caret, and that means you're going to be putting an exponent. Okay, so we're looking at 7 to the power of 7, and that's going to equal 823,543, and so that's what we're going to write here. All right. I'm not going to show my calculator for the rest of these, but I will calculate them just because the calculator has some glare on it. But you can always check the work with your own calculator if you want. So this would be 10 to, so 3, 4, 5, 6, 7, 8, 9, and 10. And that would be 2 to the power of 10 on my calculator, which is 1,024. This is 81, and 81 is 3 times 3 times 3 times 3, which is 3 to the 4th power. This is 11 to the 5th power, which is 11 times 11 times 11 times 11 times 11. 1, 2, 3, 4, 5 times. Put that in a calculator. 11 to the 5th power. We get 161,051. Here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 threes. So this is 3 to the 10th power. We put that in the calculator, we get 59,049. This is 625, which is 5 times 5 times 5 times 5, which is 5 to the 4th power. Okay. Provide at least 3 other equivalent forms of the exponential expression. Use rules of exponents such as this rule and this rule, as well as division properties and others. You should try this on your own. Pause the video, try it out. Everybody's going to get different answers for these. So you should try to get your own answers and have your teacher check it with your teacher. I'm going to give some examples, but your answers are going to be your own. So I could do, for instance, 2 to the 5th power times 2 to the 5th power. I could do 2 to the 12th power divided by 2 to the 2nd power. And I can do 2 to the 5th power squared. There you go. You can do something like that. We could do 3 to the 1 power times 3 to the 6th power. We could do 3 to the 10th power over 3 to the 3rd power. And we can do 3 to the 7/2 power squared. Because when you multiply those, the 2's would cancel. 13 to the -8 power would be, let's see, we could do 1 over 13 to the 8th power. We could do 13 over 13 to the 9th power. That should be an exponent, 13 to the 9th power. We can do 13 to the -2 power to the 4th power. That would work. Take that to the -8 power. 7 to the 1/3 power. We can do, let's see, 7 squared times 7 to the -5/3 power. That would be fine because 2 is 6/3. So 6/3 minus 5/3 would be 1/3. We could do 7 to the 9th power. And then 1 over 27 times. Okay, because those would make 1/3. We can do 7 to the 1/6 times 7 to the 1/6. Together, that makes 1/3. That would be fine. Here we have 5 to the 1 power, 5 to the power of 1, which would be the same as just 5, but we can make it more interesting than that. Let's do 5 to the 5 over 5 to the 4. That can work. We can do 5 to the 1/10th power 10 times. Or we could do, let's do one that's just adding. We could do 5 to the 1/3 times 5 to the 1/3 times 5 to the 1/6 times 5 to the 1/6. And so if you add up all of these, that will give you 1. So 5 to the 1 power. And like I said, you can get kind of creative with these. Just make sure you check them with your teacher, and everybody should have different answers here. Okay. Oh, that's task 3.4. Let's do the set and the go over here. Determine whether all 3 expressions in each problem below are equivalent. Justify why or why they are not equivalent. Okay, so let's take a look. Here we have 5 times 3 to the x minus 1 power. Here we have 15 times 3 to the x minus 2 power. And here we have 5 over 3 times 3 to the x power. So these are equivalent. The answer is yes. They're equivalent because, so look, this one, or let's start with this one. This is 5/3 and it's got 3 to the x, right? So it's 3 to the x, but you're also dividing by a 3. Okay. Now that leads us to over here. This is the same as 3 to the x, but it's 1 less. Okay, well, how do you get 1 less in an exponent is by dividing. So by putting -1, it's the same as dividing by 3, right? Those are the same. Okay, and now these two are the same because even though this is also an extra division, there's also a 15 here, and that's because that's an extra 3. So 15, you can see this as 5 times 3, and then that's going to be multiplied by 3 to the x minus 2. So even though 3 to the x minus 2 power is 1 less than this one, that's okay because there's an extra 3 in there as well. So all of these are the same. Okay, let's look at this one here. Here you're dividing 64 by 2 x times. Here you're dividing 64 by 2 x times. Here you're dividing 64 by 2 x times. So yes, these are all equivalent. I know it says justify why or why they are not equivalent. You're hearing me justify. When you do these, you should be writing your justification. Just a little note, it doesn't have to be a lot, but just explain why you marked yes or no. Also, you should be trying these on your own before looking at the answer. So if you want, if you haven't already, pause the video, try it on your own, and then come back and answer. And remember, you should be writing explanations for why. Okay, this is 3x minus 1 plus 4, 3x minus 1, 3x minus 2 plus 7. Okay, well, to know if these are similar, let's do some distribution. So this would be 3x minus 3 plus 4, and the minus 3 and the plus 4 together makes plus 1. So this would be 3x plus 1. Already that's different than this one. So no, these are not the same. That's a no. Okay, let's look here. We have 50 times 2 to the power of x plus 2. Here we have 25 times 2 to the 2x plus 1 and 50 times 4 to the power of x. Okay. So the question here is this the same as 4 to the power of x? I don't think so. I don't think so. So because 2 to the power of x plus 2 is the same as 2 to the power of x times 2 to the power of 2. 2 to the power of x times 2 to the power of 2. This is 4. And so I can get a 4, but the 4 doesn't have the x, right? The 4 is not the one that's being repeated, or the 4 is being repeated here, but the 2 is what's being repeated here, and that doesn't add up, right? So if I raise this x by 1 each time, or just if I continually increase it, every time that I raise the x by 1, I'm multiplying an extra 4. Every time I raise the x over here, I'm multiplying an extra 2. So that does not match. So the answer here is no. Those are not the same. I didn't even have to look at that one. Okay, let's look here. We've got 30 times 1.05 to the power of x. Okay, that's just like in the task. Here we've got 1/7 and 7. Exponent rule says that these multiply and cancel out. So those are actually equivalent. 30 times 1. Okay, and then these, so exponent rules say that when these multiply, these cancel out. So these are actually equivalent. All of these are 30, 1.05 to the x, 1.05 to the x, 1.05 to the x, because these cancel out, and those cancel out. So yes, these are equivalent. Okay, now let's look here. 20, do they all have 20s? Yes. 1.1 to the x, okay. 1.1 to the -1 to the -1x. Well, exponent rule says these are going to multiply, and -1 times -1 is +1x, which is the same thing as x. So these are the same. And here exponent rules says these will multiply. 1/5 times 5 is also 1x. So yes, these are all the same as well. Okay, so the answers were yes, yes, no, no, yes, yes. If you didn't quite understand that, have your teacher call them over and have them explain it to you. Okay, let's go to the go. It says simplify each expression. Your answer should still be in exponential form. Okay, so here we've got 3 plus 5 plus 2. Using exponent rules, we know we can add these. So 3 plus 5 is 8, plus 2 is 10. This is 7 to the 10th power. It says that my answer should still be in exponential form, so I'm not going to plug that into a calculator. 3 to the 4th power to the 5th power, exponent rule says I multiply these. So that should be 3 to the 20th power. Okay, 5 to the 3rd power to the 4th power times 5 to the 7th power. I should multiply these and then add whatever is left. So this would be 5 to the 12 times 5 to the 7, add those, you get 5 to the 19th power. Okay, x to the third times x to the 5. This is just x to the 8. X to the negative b. So this is going to be 1 over x to the b. Right? You're dividing by x to the b power. X to the a times x to the b. You're going to add a and b together. So this is x and a plus b goes in the exponent. X to the a to the b. This is where you multiply them together. So ab goes on the top. Here we've got a division. So these exponents will be subtracted. This will be y to the a minus b. Here we've got another division, but we can multiply these first. So this is AC minus B, y to the AC minus B. 27, we've got a multiplication here and then a subtraction there. So this would be 3 to the 24th over 3 to the 7th. Subtract those, we get 3 to the 17th power. Here we've just got a bunch of subtractions. So r to the 5th over r, that's going to be r to the 4th. S to the 3rd over s squared is just going to be s. So 5 minus 1 and 3 minus 2. And those become the new exponents. Over here, for these exponents, these subtract. We've got 5 minus 8, which is negative 3. So we can just leave that on the bottom. X to the 3rd power on the bottom. Y to the 12th and y to the 9. So we can do 12 minus 9, and that's going to give us 3. And z to the 0 is just 1. This is just 1. We don't have to do anything there. We can just leave it. So that's the answer here. And that is the end of task 3.3. I hope you understood. Again, ask questions, internalize, don't just memorize, make it your own. All right, see you for task 3.4.